To sketch the graph of the one variable inequality solution, we need to know where the boundary points are. And basically the boundary points are going to be where it is equal to 0. Okay, so if we want to know above or below 0, we need to know boundary which is equal to 0. So to find equal to 0, we're just going to solve this as a regular quadratic equation equal to 0. In this case, we can factor this. So x minus 6, x plus 2 is greater than 0. And this gives us our boundary points. Okay, so these then represent the zeros. X equals 6, x equals negative 2 represent boundary points for our solutions. In fact, I should erase this and just leave it as line because the boundary point is not included in this solution. Okay, so if I want to solve this then, I have my boundary points and I'm either going to go inside like this. Okay, that's an option. I can go on the outsides like this. Okay, but basically I can just figure this out by testing regions. Okay, so that if we're ever stuck, we can just test. So if I want to do a test, I'm just going to do a test over here. My test of my regions. I'm going to test x equals 0. X equals 0 is really easy. So I end up with negative 12 is greater than 0. So for 0, this is not a solution. Okay, so then I can probably guess that my solution is going to go out like that because of my test. Okay, I can really test the other regions though. I should test some number out here. So I'm going to test maybe 7. So x equals 7. Okay, when I plug 7 in, I'm going to put it in the factored form. I'm going to have 1 times 9. So I'm going to have 9 is greater than 0. So that is a check. So we know that that is part of the solution. So it's got to go this way. Okay, so that's my boundary point. It's going to go to the right. I can check maybe x equals negative 3. So x equals negative 3. If I plug it in, I end up with negative 9 in the first bracket and negative 1 in the second bracket. So I get negative 9 times negative 1, which is positive 9. And that again is greater than 0. So that again represents part of my boundary region. So I know it's going to go out like this. So there's my solution. Okay, it's going to include my boundary. Or sorry, it's going to not include the boundary and then go out. Now, a much more efficient way to solve this problem would be to imagine what the quadratic function looks like. So if I imagine what the quadratic function looks like, I'm going to imagine a quadratic function that has zeros at negative 2 and positive 6. And if I take a look at the a value, it is positive. So I know that the parabola is going to be facing up. It's going to go through the zeros like this. And there it is. Okay, and then my solution must be where it's above the x-axis. So my solution is going to be all this, which translates into that section. Above the x-axis is all here, which again translates to that section there. So there is a way we can do this by imagining what the graph looks like and determining what part of the parabola is above or below the 0 or the x-axis. If in doubt, we can always test. Okay, so we can always test our boundary regions by just plugging in numbers in the different regions based on the 0 boundaries.